See if I can rock the glasses today. Hell yeah. They're not terribly blurry, they're just slightly blurry. I need new lenses. Bonk. Ta-da. Bum bum ba ba bum. God, if I sit super tall, my head's off the screen. You'll understand him eventually. It's fine. Hello, welcome. Time to figure out where I left off. Let me pause my stream here because I never do. Everything should be on. Mic is on. Cameras are working. That's good. Okay. So when we said populate, we did this. In the module, we have this. And for anything that isn't a scope or a namespace, it goes into the scope. So now, what have we done in the past? We're attempting sema. Okay, so now we've got to do this. So 70. Bonjour. So I haven't found the declaration. I need to look up their imports. So string view current name. Well, okay, hold on. We're at the first name here. Name index. Is it 0 or 1? Okay. So if name index so we're assuming at this point, since found declaration is null, then this is 0. So it's first. So assert name index is equal to 0. And also, I need to worry about refactoring. That's what I needed to do. Static Laye node, Laye summa, lookup value with it, lookup entity with it. In scope. In namespace. We're just going to say lookup entity and I'll figure that out. So we need to start at a name ref from a module from a sema. Let's say bool is type. That'll be the start. So let's grab the entire implementation here without breaking it so I can compare. Search scope is scope, piece is string value. So this is lookup value. Let's just trivially say, is it a type entity, lookup type, else lookup value? lookup type that. Right? So that minimize this one. Should be lookup type up. Same for this one. Okay, so then search module from found declaration, this thing. If we didn't find a declaration, and this. So what's the difference between these two cases? Is not a value in this context. We want to do this first. But if we've done found declaration, index should not have changed. It'll be 0. If we did find a declaration, but there's more names left, then here it's saying, hey, yo, maybe I just rewrite this shit from scratch. Because the logic here does not sound good. So search module is from module in this case. Let's see. So found declaration. If we didn't find a declaration, then we need to go down the path of imports. Straight up, that's the first thing we got to do. We have to find a declaration. So search module is from module here. So looking up an entity from this module along this name ref. This is so we can dig into imports should we need to. Imports have a module that they reference and a list of entities. So we search the entities first. And then if we don't find anything in this list of entities, we set the search module to this, which will then go through its imports. And the list of entities in the import is only the things that we've exposed. We're not looking through its declared anything. Because the import defines which things we care about, which could be everything, but it could be not everything. So we only need to search the module if the found declaration is equal to null. If found declaration is equal to null, we do a thing. Do you have a good name for a program? It gave you some like 6 months ago, and I've forgotten all of them. But it only took me like 10 minutes to come up with Hibiku, so you can figure something out in 10 minutes. It might get hot in here. Let me preempt, get some cold water, and turn the AC on. Okay. Water required. Perfect. So, if we found a declaration, we can search through a module, or if you have not done. Okay. Those are the two things we'll probably be updating. So next, what is search module reports the array count of this. I is less than that count I plus plus. So then dynamic array Laye node imported entities equals search module imports sub I dot entities. And let me get it. Fine, good. For int 64tj, of course that's what we're doing now. 0. J count is, oh, that's wrong. Imported entities. J is less than J count. J plus plus. Return to that. That'll be better. So then we have a Laye node imported entity is this sub J. Assert imported entity not equal to null. Then we want to check something. Problem. Not problem, but something I didn't consider here. So first, we search through all the imports. First thing to check is I guess order here might not matter. We want to look up a name. We could look up the namespace, or we could look up explicitly imported things. We should probably prioritize these if it's the last name and these if it's not. So let's say bool is last search name equals, we need an I. I need to track my name index instead of doing this, right? So int64t name index equals 0. His last search name equals 0. So we need to iterate through the name probably. So this could be its own loop. Let me kill this. Hold on. Let me start rethink. We need to go through the name left to right until we hit a declaration. We want to start with explicitly imported names from the import query and then do namespaces, import namespaces. And we want to do, rather, we want to switch on which of those we do first, depending on the position in the name that we're at. So let's start here. For int64t I equals 0. We're going to call this name index. Name count is our count name ref pieces. Name index is less than name count. Name index plus plus. Bool is last name equals name index is equal to name count minus 1. Okay. How do we, what are the two things we want to do? We want some way to get one or the other. So we want to look through queries of all imports first. We should probably make this a function. Static Laye node, or here's the problem, either a node that we find or it's an import. Though I guess not, because a query can only ever resolve to a single name, and it should always be an entity. I think we're not currently doing this, but I think, well, how do we want to handle querying and namespace from within a thing? Right, so libc here we're querying standard IO, its namespace, which is what I'm doing here. Imports the standard IO namespace as standard IO3. So yes, if we're allowing this, then this is going to resolve to another import, one of these. So if I break this out into a function, we have to be able to return somehow either an entity or another import. So maybe I mean, if it's recursive, then it's fine. But if we hit something here, then we want to prioritize it anyway. So I think that's fine. It should eventually return a node. But it should still. The order of operations here. Order of operations. Because the next thing I'm thinking of is if we have like standard IO printf, that's two names, and we start with standard IO and we find a standard IO and we go into it. But if we eventually get to there's a lot of little things to keep track of here, so I'm not sure how to explain it. Struggling to explain it to myself in my head. The other thing we could do is just disallow at the semantic level any of these names clashing with namespace names. So if this namespace clashes with anything that's declared in module scope, which would be any of the import queries or any of the functions or variables declared in here, then that's a semantic error and we don't have to worry about it. So then I don't have to do one order or the other. Let's assume that I can do that. I'm not currently. So I'll make it a to-do. Redeclaration of name as an import namespace should be a semantic error. They can't participate in overload resolution. But it should just be disallowed for simplicity. So for now, we're going to not give a shit if it's the last name just yet. We might want to know. I don't think we want to know here. If we do, I'm going to leave it there so I can think about it. So we're going to go back to iterating through all the imports. If we match the name, we'll start navigating through that import. If we match a query, we take a look at what the query matches. So I guess this is another thing we're going to have to look at. Does my query, because this references imported entities, but it should also reference other imported modules. So that's something that we're lacking here. Which actually is interesting. Because somewhere down here, handling module imports, we do something somewhere. Let's see. Resolve import queries. Aha. We don't do import queries yet. That's part of the problem. So an import query needs to either be a list of entities or another module name. So, I don't know why I did that. We want struct Laye module import, which we can't do. We'd have to do it by pointer. To be a module. You just call it an import. So then we need to be able to switch on these two. Made my life difficult, haven't I? Ba, 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 ba. Boom. But an import references a module and all the entities that it hits. So really, I don't have to switch. I need a dynamic array on imports. So it can import any number of entities and any number of other imports. But then these are going to be copied over by value, which we don't want. We do want it to be by reference. But then as soon as these get resized, these pointers become invalid. So instead of being a module import, it should just be the other modules that it references. Imported entities, imported modules. Right? This should probably return an import. The module it references is module. Return results. That's why it wouldn't. I guess so. We're generating these import infos at this point that are going to go into the import array. So our push module import the import info. Right? Right. Now I'm not sure these data structures are exactly what I want. I may have to change things again. Why is this harder than it needs to be? Why is this harder than it needs to be? Anything that queries entities. Hello world. Hello Aquais. I am for some reason struggling to wrap my head around the data structures I need for imports. I'm not sure why. So I really only need two distinctions, and it's one that generates a namespace and one that doesn't generate a namespace. Right? Anything that does generate a namespace does not do this, which is this. Anything that does not, for the most part, I'm a little tired after eating food. Usually happens. So this should still be fine. We grab all of our import info though. Resolving import queries is going to result in two things: imported entities and imported modules. So I don't actually need to do this. I don't know what the point of this was. Am I using this anywhere yet? We're freeing it, and we're pushing to it here. So we don't actually use it yet. This import should be imported namespaces. Right, that's the purpose of these. Anything that generates a namespace. Which is these two. We'd put standard IO and standard IO2. Those would go in here. libc and libc2, those would go in here. Potentially, this would also mean anything that resolves to another namespace. So standard IO3 from libc would get put in here as well, and those would be the 5 namespaces we have. And then really, does this need to have these then? It needs the referenced module for sure. But once we've resolved that it's a namespace, there's no queries, so this is useless. And at that point, we just want to search for exports only. Right? So we want to search for exports and other exported imports from here. So for an import, right? Oh, I need to mark all these as exportable too. So we have exported declarations and exported imports. And anything that is within an import can also be re-exported. I might have to completely change these data structures again to support exports as well. Fuck. Handling module import is responsible for loading the module and recursively handling loading modules. The only job is to parse recursively. So that's done. By the time we have recursed all of the parsing, if I, for example, just return here, what we're looking at is that doesn't return anything. Yeah. Which function is this? 77? Way the hell up here. This is going to have to be written. So this gives us just the import. I go back into what is this printing? We're asking for it to print all the imported modules, but I'm not seeing other modules here. And also, this should probably prefix itself with the name of the module. So then we want to append format. I don't have a name. Source ID. I have a source ID. So Laye source. Yep. And then we want the color to be like color reset or color red. Color, we don't have like a comment. Try bright black and see what happens. So color comment, and then color reset. This. Okay. So this will give us just, oh, not what I wanted. This. This will give us next import Laye, but nothing else, which is strange. Because if we're, welcome back, if we're actually handling these imports, we should have two other files printed. So that's problem number one. Laye modules are context Laye modules every time we parse one. So then in Sema, when we handle module imports, let's set this here. Go into our launch, tag the IR for test Laye import. Or not the, do the AST for test Laye import. That's what we're doing here. Oh. I was experimenting a while ago, and that is not correct. So the lookup path standard IO. We've determined that standard IO exists. Source ID is 1. But the module source ID is 0. This source ID is 1. This module source ID is 0. What the fuck? Found is not equal to null. And then we're looking at found, not module. That's what assert found is not equal to null. Then referenced module is found, handle found. That continue found is equal to null. It is still fine. Okay. So then if I come here, found should equal null. It is null. So this will not happen. What? I didn't recompile. So just not place. There we go. This will parse source ID 1. Let's just continue. And there we go. Now we have those 3. So if I come back up here, we have standard IO and libc. And we're not re-importing any of them multiple times. There's only one instance because it does know which of these files is. I need to canonicalize these names to guarantee this, but this is fine. So then we've got puts and printf from standard IO, and we've got libc's standard IO import. That's step 1. We have figured correctly that we are resolving imports. The next thing we want to do is populate import scopes. This is what we haven't quite finished. I mean, we have, but it's not for this one, and this is probably wrong. So this is probably fine. Not with this type specifically. This type is probably not fine. So an import namespace really is just a reference to the module. And from there, we don't do anything else with it. So I do need a different data type to return here. Grabbing these imports as well as a list of nodes. So let's say this with a dynamic array Laye node. Oh, but problem. I also need to include the alias. So just a node is not enough. We also need the alias name. So I'm going to need an associative array to handle those lookups. Second problem, we're not doing that here. We're just redeclaring the entity. This is probably where I want proxies. And then anytime we do a lookup, if we hit a proxy, we navigate through it. Returning the actual node, but being able to reference it by a different name. That way I don't have to do another lookup. And the alternative is just an associative array at a different scope. But I want these to be resolvable easily in overload resolution. So I think we're going to come over here and make proxies to make my life maybe easier. Laye node proxy is node create nodule Laye node proxy deco proxy like this, and peak location and the same type as the entity. So we need a declared name here so that we can look it up. So then this needs to be more than a Laye node. This needs to be just a node with alias. Let's just call it that. Like that. Then this becomes a list of aliased nodes. Imported entities. And then we also want a list of aliased modules. And an aliased module is just an import. So this can go here. Hello, Mark. Everything else. So then this import info is what's returned. An import, if we're resolving import queries, we don't care about the module being returned. That's fine. So summa import info. Then we have imported entities. This is imported modules. So then for each imported entity, we grab the entity. I need to use a different type here. The entity is this.node. Then the proxy only needs to exist if there's an alias. So if entities sub I dot alias if alias dot count is greater than 0, then we're going to generate a proxy. At the very end, entity will become that proxy and we'll declare it in scope. The declared name will be alias. So then let's go into Laye node real quick. I'll give it the full name. That. And then I need to go back and look at kind. That's IR. Interesting that it takes me to there. Okay, so Laye node. We want to come up here to declaring the nodes. Echo proxy. There it is. Then we declare it. We may as well set its declared type as well to entity declared type. Then this is correct for importing entities, I believe. The next thing we want to do is grab the actual imports, imported modules here. is we want to iterate through all these modules, adding them to our current modules imports. So our push module, current module here, imports a new thing. The new thing will be Laye module import. This is going to have to be wrapped in doing it hidden. Let's see if this works correctly. We need a name equal to module sub I dot name and a reference module equal to, wait a second, we're doing a Laye import module. We're just gonna fucking, what am I doing? Sub I, like this. Append it to our current imports here. I think that makes sense. So then we just need to resolve all of these imports through this query here. The alternative is generating the import namespace. So here, we're going to do the same thing, but we need to have this. So dot name dot referenced module is going to equal decal import referenced module. And the name is going to either be the name of the module, which we have to calculate, or the alias. String view module name is going to be this import alias. Right, that's step one. The import alias is a token, so this needs to be string value. The whole thing should be 0 if it's not there. So if module name is equal to 0, we need to calculate it based on the file's actual file name. So we're going to start by saying module name equals a thing. We need to grab our import alias referenced module here. And we need to say Laye get, Laye get source from module. We have a context already. From the context, this source ID, get its name. And this name is owned, so we want string as view. Like this. Now we have a module name. Then let's say int last slash index is going to be max I. That's what we called it. We're on 339. This was declared up here. That's fine. So max I of something. This is going to be why is my brain slow? String last index of module name slash and backslash. Okay. Works. If last slash index is greater than or equal to 0, then module name dot data plus equals last slash index, and module name count minus equals last slash index. If, for example, we have foo.laye with 1 slash, this would be plus equals 0. So we really want to chop it off one extra character. So I'll just +1 like this. Right? I think that makes sense. At the end of all this, I'll fprintf standard error calculated module name mod.*s expand of module name. That. So then the next thing we want to do is int, and I think this is int 64. Int 64 first dot index is going to be string view index of module name dot. If first dot index is greater than or equal to 0, then we want to set the count equal to first dot index. Right? So if we ended up with dot Laye somewhere, then 0 would be the count. That's the first index. So then we have a couple of things to do. We need to validate that the name is a valid Laye identifier, which means it must have more than 0 characters and only contain valid identifier characters. So if module name dot count is equal to 0, then write error in context at the top level node import decal import import alias, not alias, module name location with the format could not create a explicitly create a valid Laye identifier from the module file paths, right? Otherwise, we want for int 64t I equals 0, I is less than whatever count is. Count is our count of module name. Now, count is just module name count. So I is less than. Oh, see, here's a problem. We're in I already, so this needs to be a j. J is less than module name count j plus plus. If what are we doing? What you want? What you want? I can't believe you would come and join me in my live stream, begging me to play video games with you. Not right now. Probably soon, because I don't have that much stamina for this, but not till I figure out what the fuck I'm doing. Then maybe. Then probably. I'll see you in like probably half an hour to an hour. Okay. So if we need is identifier character, which we have in the parser. We just don't have it anywhere else. So we'll put it here, just copy paste. No reason not to. If not is identifier character. Module name data j, then write error and break. This error will be, well, I mean, it could be the same error. We can get more detailed later when we make sure it works. That's a good enough same error. So at this point, it doesn't really matter what the module name is, and we're not leaving here, so I'll put that there. So that gives us something else to do, which is all this shit. So we've put it after populate import scopes. This query system doesn't do anything yet. We can run this and it won't be recursive in any way. It won't technically work. Oh. This needs to say index of. What about that? What is this? Use of an empty initializer as a C23 extension. You're correct. It is. There's going to be a 0 for now then. So this works. We still get all 3 of these. We calculated module name. Standard IO. I didn't include a new line, so it's going to look a little ugly. We'll just do it like this. So we've calculated standard IO, libc, and libc again. Why would we calculate libc twice? This should be the only one that needs to calculate it. What the heck? Let's change this to a write info in context at the import location that we care about, which is top level node deco import module name location. This. Right, instead of being info, do I have other writes that are going to be prettier? Note. We'll write a note. 2635 and in libc.laye. Really? libc.laye. What the fuck? I'm using the wrong thing, aren't I? Standard IO.laye. So, calculated module name standard IO comes from import line 26, which is here. That's correct. The next thing, 26.8, by the way, is right here. Yeah, that's fine. The next one is 35.8, which is here. That's libc. Oh, I should probably make this a touch bigger for people. And then finally, libc laye 315 calculated libc. But it should calculate standard IO. Where the fuck is it getting libc from? Standard IO. Let me go back into debug. We're going to do something here. Here we're printing this. We're going to include mod p. It's actually going to be mod 016 XL. Yeah, 016, but these should all be capital X. Address. Right? Okay, so that's here. 016x, size T. Is it normal the mic is clipping under certain threshold? Probably, I'm just not talking very loud. This is size T. If it happens while I'm actually talking at volume, let me know. If I'm kind of mumbling to myself, I wouldn't expect it to be perfect. Model. So we're referencing this module. This isn't going to tell us anything yet, but this is... What the hell? What? What? Hold on. Node debug print here has this message retracted. What the heck? 016 LLX. That's probably what we actually want. Let me go find 016 and replace it with LLX. That's step one. Step two, size T of whatever there. Okay. Size T of module should still work. Why is this ugly? That's better. It was probably getting the upper 32 bits. Still very interesting addresses, but... Okay, so then anytime we do decal import here, we can print this stuff. If it has an alias, we do an alias. And then the final thing is if the referenced module is not equal to null, we then want to print mod s, and that's color header, and size T of the module, which will then be mod 016 LL capital X. So this is referencing itself. What? 507 and 100. It's referencing itself. That's absurd. Where is it getting this from? What? Oh no, I'm not gonna have to run all of parsing and or sema through a debugger. Let's throw this here. This is the source name of the decal import referenced module. Source ID. Which should not be itself. That's one place I want to break. Another place I want to break is handling module imports. When we get this lookup path here. So in the first one here, our lookup path is standard.io.laye, which is coming from top level node. Location is source ID 0, it's this one. Length is 6. That's for the word import. Offset is 1069, which doesn't help us right now. It does actually, if I come over here and I say this. No, that's get. Go to byte offset. I don't remember what it was. Character position index is kg. So if I kg 10069, I didn't do anything. KG10069. That's here, right? So that's this one. This one is resolving this in here. So I can step over. That'll give us a source ID of 1. It's the second file that we've loaded. Blame the compiler. Well, which compiler? My compiler or Clang? It's hard to blame Clang. So we found a module, or we didn't find a module, we parse a module. The found module has source ID. If I hit continue, this should be the same name, lookup path, standard IO. This should be coming from this location, which is 1127. 1127 is here, which is fine. That makes sense. If I continue again, we should be at line 30 here. Line 30, 1207 is this one. It should again be source ID 1. Source ID 1. Continue. This one should also be source ID 1. I'm just going to check it. Source ID 1. Cool. It's going to find source ID 1 right there. It's going to reference source ID module, or reference module to source ID 1, which is standard IO. So that's all 4 of these. This one, libc.laye, is going to do a couple of things. We're going to reference it, and when we go to parse it, when we go to parse it, we should end up here again with the recursive handle module imports call. So continue. This one, the lookup path says deps libc, which is where we're at. That is going to exist and give us source ID 2. Okay. The next place we should be is looking for lookup path deps standardIO.laye, right? StandardIO.laye does exist. This location should be within libc. So if I go to top level node location, it's at offset 28, and its source ID is 2, which is this one. Offset 28 is right here. So this is all correct so far. If I step over, we get source ID 1, 1. Okay. So then it finds module with ID 1. It sets it to whatever. We continue, we exit. On exiting, we go to the next one, which should be the next libc here, line 37. So if I continue, lookup path should still be libc. We should already have found libc, so it should return 2. The current location is 1441, KG1441, which puts us on line 37. This should return source ID 2, which should get found right here. So then this gets continued. I did it again. Found. Now it's referencing the right thing. So then standard IO, libc, standard IO. That is correct. We done did it. We fucking used the wrong goddamn variable again. So then down here is where we're calculating the name. But we've already determined that we fucking fixed that. So that's fine. Now at this point, these are all of the references to modules, which is fine. Then now we need to handle actually traversing these queries, which is here. So the result here is just 2 arrays. Since it's just two arrays, we can actually zero in it just fine. Hello. Okay. So we now need to iterate through everything. And all of these are going to be pretty easy except for this one. This one's going to take some work. It's not going to be a lot of work, but it's still going to be work, probably. So, and I don't think in any case here we're going to get an overload set. We just want to find everything that shares the name. So let's just iterate through. 4 equals 0. Count is our count of that list of imports. But it's not called imports, it's called queries. The list of queries that we're importing. I is less than count, I plus minus. We're querying that module. So goldfish. If we grab the query, Laye query. Oh, it's just a node, that's right. Our import query is just a node. Query equals queries at I, sub I. Search query exists, so we don't have that issue. If query dot query dot is wildcard, step 1. Else, and if it is wildcard, we're just gonna continue. Because wildcard is an easy one to handle. Adjust the way I'm sitting, moving things around here. My leg's gonna go fucking numb in like a couple minutes. But it'll be fine. I'll be comfy until then. If it's a wild card, really, if it's a wild card, we should break. Even better, do I track wild cards at the node level here? Or we do. But I don't have access to it here. I just have the import queries. So if I just do this, then we don't even have to iterate everything. If it's a wild card, then we iterate if it's not. Because it's sema, at this point, the error's already been reported. We only care about one thing, I think. Because we're not going to get here if the error's been reported already. So then down here, we want to resolve queries. It is wildcard. So then here, the easy case, we should, if query is wildcard, should still skip it, just in case. I don't think it's going to happen. Like, I mean, yeah, whatever, right? So if this is a wildcard query, we want to import everything that has been exported from this module. So module is going to have top-level declarations, top-level nodes, and it's going to have No, that's all we care about. That's all we care about. I think where this is probably going to get more complicated is semantics around importing exports, which we have decided is possible. How do we want to handle that? What I'm referring to there is here we're just exporting effectively star from, but in the standard IO namespace. If I export import something from here, we need to include this in whatever we're importing. And don't know, since we're trying to allow circular references through imports, I don't know that I can guarantee that this will already have been resolved without doing a dependency tree, in which case we'll have to have circular dependencies in import queries. I mean, I can ignore the problem for now. I can ignore the problem for now. The ideal solution is that we resolve import queries in the order that they need to be resolved in. Which I have a mechanism for. But it will mean not doing these in the order or the manner that we're currently doing. So saying populate module import scopes here means that we don't want yet to populate this module scope with any of the declarations. We actually want to generate these proxies and or the only way that these can have a dependency cycle is if an import query depends on another import query. So maybe this is fine. We can always avoid that and work around it until we find a real solution. So imports are strange. Why imports gotta be strange? Or I wanna do some more debug printing. So in here, we have our list of import queries. Wildcard actually, so what I'm currently doing here is I'm returning this import info for resolving all of our queries. What might instead be useful is the result of the query itself being stored back in the tree. I think. Trying to walk myself through that. The primary use is debuggability. I can now print them in this AST viewer. The same way I did this, I can print references to these nodes, right? The second thing would just be not duplicating this. I would populate these and just reference these directly. This would also mean that if something has a reference to an import query through a dependency tree, for example, it can look at everything it imports. Question mark. Does that make sense? So if I then instead were to turn this into void, we'd want to wrap this in a loop to go through every query again. Do this. I hate to stop here, but I might need to take a break and get back to this separately. I can feel my wheels endlessly spinning. I'm going to make this void before I go, as a reminder that that's what I'm doing. And I'm going to change the signature. Import query singular. And then it doesn't matter if it's a wildcard query or not. We're just going to hit that. So then what we do over here is we resolve import queries, except we for int 64t not at I, we want to be at j. We'll see if this makes me feel any better. Count, j count. If this makes me feel better about what I'm doing, then we'll continue. If not, I need to go take a break. J count is going to be array count of these queries. So let's do dynamic array by a node. Queries is this. Queries j is less than j count. J plus plus by a node query equals queries of j. Resolve a single query which does no longer need this wildcard flag and only needs queries of j, which is query, like this, right? Then what we're going to do is copy all of this into here. Instead of this, it's going to be query, query, we're on I again. It's going to be annoying. So for K, array count of import query. Why am I not getting? Import query, imported entities. K is less than K count. K plus plus. Then we say K And this is sema, that's probably why. A sema aliased node should probably be a proxy node that we generate up here because we're aliasing it. So this would be Laye node imported entities, right? This is also probably why. This is no longer queries, it is query. YouTube is not receiving enough video to maintain everything is dropping, so I am dropping every frame. It's probably because my friends started playing a game and then streaming that game in a Discord voice channel. Maybe not. Somebody else is streaming, not them. I don't know why I'm dropping frames. My bitrate is tanking though, which sucks. Well, if the bitrate's going to tank like that and I'm going to drop a fuck ton of frames, that's probably my cue to just go. Because there's nothing I can do about that. Nothing I can do about that at all. For me, it looks fine. Okay, I'm going to keep going, but I'm not going to keep going for very long. Right? We're going to fix these compile errors, get where we were going, and then go. So query doesn't need .node anymore. It just needs imported entities k. Right? Then alias doesn't need to happen anymore. We're going to put the alias up here. Remind me that we have to proxy aliases. Assert that it's a declaration, add it to scope, it's already going to be a proxy. Asserting that it's a declaration, kind is decal, less than or equal to decal template value. Decal template value. Well, that's wrong, because decal proxy is now the highest declaration. Okay. Glad we checked that. This. Well, that just imports everything that we got from the query. The second thing we do is for every module import, and again, this will be k count. K is less than k count. K plus plus. This will just add this to our module. Now we don't need this. Next needs to go there for. Okay. So then the next thing we have to do is implement walking through import queries. Walking through import queries is going to mean we see printf, we have to go find printf in standard IO. That's fine for just looking up a regular name. We just go through all of its exported declarations. Problem, it could be a thing. Well, no, not problem. It could be either an import declaration, in which point we need to generate a module import, or it could be a function or a type or something, in which case we do an entity import. We want to do that for every match for the name so that we can generate overloads. And then we generate an alias if we have it. The problem that's more complicated, I already mentioned, is navigating through other imports. And wildcards will kind of include that. It's not as big a problem for wildcards. So let's at least make sure this, that's not my terminal. Let's make sure this runs. It does not. We hit false and unimplemented. That's because that was here. We're not traversing any of the queries yet. But it looks like there's no errors. I can remove the calculated name thing. So starting at the top, what I want to then do is I was going to say, oh, I could just append all of the imported entities, but I don't want to get entirely too recursive if I can help it in the printout. And I wouldn't be able to do it for imported modules anyway. So I'd have to like wrap this in a node to print it, which is not ideal. So I don't know if we're yet going to print queries here. It's interesting that everything gets a colored background and goes black, except for green. Green just works. Very strange. Blue, green, just green. Even the gray gets different. Why is green special? Just does it? I don't know. Okay, so I've got to figure out how to do this query mechanism in as sane a way as possible, which might involve me going back and generating dependencies for these imports. I'm not sure yet. I'm getting a little tired, and apparently I'm dropping frames, even if it looks fine for some people. So I'm going to call it here. You might see another stream like this in a couple of days. I might do this off stream. If you would like to, if I do it off stream, you'll definitely hear about it over here. I talk a lot about it in development. So if you want to join the Discord, it's in the description. You can come do that. Announcements whenever I go live. We might do a Hibiku stream next, though, to get my mind off of these stupid imports that I can't figure out. So yeah, if you want to see the source code as well, it's in the description. I won't probably push, I might push this right now. Let's see what we've got. Cool. Everything is synced up to Git on GitHub right now, so if you want to go check it out, go ahead. I would love if you started. We're up to 26 whole stars now. That's a lot. Actually, I didn't know that. Forget if you want. I don't care. I'm going to be updating this README with a bunch of extra docs sometime soon. I'm in the process of updating the README right now with a bunch more information on, like, detailed information on building it, more detailed information on the wiki that I'm going to start writing, stuff like that. There will be documentation for the language, the compiler, all that kind of stuff pretty soon. And actually, I think everything in here is good to go. I was putting it off because I was tempted to change the build system, but this sounds like it's not worth doing, so I'm just going to get out of README as well. So there's an updated README. It'll get more up to date, and I'll be adding docs that'll be on the GitHub wiki. There's a docs folder here that just has the wow, look at the wiki thing. So if you go into GitHub and the wiki, this repository is like a sub-repository, a sub-tree of the repository, the main repository now. So you'll see these docs get updated. So it'll be easier to use this repository for yourself. I'm going to try to figure this out. If you want to go follow it on GitHub or see my updates in the Discord, you know how to do that now. Thanks for joining in. I'm going to go relax, not think about imports for a little while. Bye.